Great. I just wanted to give you some exam updates and then we'll do the notes. So I was on a video call the other night with the college board. They said there's not going to be any calculations. So originally they said all the calculations will be able to be done without a graphing calculator. They have now said that there are no calculations you have to do. There is also no graphing or drawing. And the test starts exactly at 3 p.m. our time, but you're going to have to log on 30 minutes before in order to fill out all of the security questions. They've already caught a kid trying to cheat. The AP exam has not happened yet, but he was planning on cheating or having somebody take the test for him. And so they're reporting that to all of the colleges he has applied to. So if you have technical difficulties, like the power goes out, your computer crashes, something like that, they have a backup plan. They know that these technical difficulties are going to arise, so there's going to be a form you can fill out to take the exam on the makeup date. Just a reminder, it's May 18th, which is a little over a month away. 2 free response questions. So there's the experimental design free response question, and then the problem solving one, which is the problem solving one's going to be more like the free response that you've seen in my class so far. But we've done a lot of work, especially at the beginning of the semester, on independent, dependent variable hypothesis, and all that's going to be the first free response question. So again, we have plenty of time to prepare for this. I think you guys are totally ready. And don't worry too much. We'll have tons of information for you as it gets closer about how all of this is going to work. But for today, let's finish chapter 13 and be done with all of these chapters in the book, so then we can just focus on the exam. So wind energy, all right? You guys are probably really familiar with this. You've probably seen these turbines out on the landscape. So it's just wind that moves through the turbine. So the turbine's the actual like blades here. And just a reminder, winds are created because the earth is heated unequally, right? This whole idea that warm air rises at the equator and cool air sinks, all of that creates a wind, a difference in temperature. It's the fastest growing source of electricity in the world. And you'll probably see lots and lots of these, or lots more of these, as you continue on in your life. You'll notice that these on the left-hand side are in water, so you can actually put wind turbines in water. If you think about it, out in the ocean, they're not going to disrupt anybody, and there's plenty of wind out there. So that's one option, or you can do them on land as well. So just a quick recap, electricity. You guys can probably figure out the basics because all of these electricity generation techniques are very similar. So the wind blows, right, turns these turbines. So this is the actual turbine, right, with these blades. And then that turns the generator, which produces electricity, right? And then it can go to your home. Same thing that we've been talking about for all of the other electricity generation types, like whether it's coal or whether it's nuclear, all the same types of things. We have to get something to turn the turbine, usually it's steam, and then it turns the generator and creates electricity. Just to show you, we do not have as many wind turbines as the rest of a lot of the world, especially developed countries. Europe is actually really awesome at wind power. So you don't have to write anything down for this, but I'm just showing you that top wind producing countries. This is actually, I'm going to ignore this graphic because this is not showing me what I want it to. So what are the pros? It's non-depletable, meaning it's infinite. We can never run out. It's renewable, right? It's clean and it's free. We don't have to pay for it. Okay. There's no pollution that we make. So we don't make CO2. We're not releasing sulfur or mercury. There's no greenhouse gas that's created. We can also share land with other places, whether it be houses or farms. We can put, buildings below them or roads. What are the cons? Batteries, right? We know batteries have toxic metals, they're hard to dispose of. So a lot of them use batteries to store the electricity. There are animals that can be killed in collisions because they fly into these towers. And then noise, they're not super noisy, but they do have a little bit of like a whoosh, whoosh sound. And then aesthetics, meaning they're not that pretty to look at. So here on the right-hand side is an infographic, right? And it says wind farms kill fewer birds than most other hazards, but pose a particular threat to species, including raptors. Estimates of fatalities for the US are highly uncertain. So this is just showing you the number of animals and birds that are killed each year using these different things. So for example, buildings, all right, 100,000 to 1 billion birds hit buildings and then end up dying. Cell towers, 5 million to 6 million. Cars, 60 million to 80 million. And then, and cats, 365 million. So then we look at wind turbines, 100,000 to 440,000. So even though they might affect birds, they're still a much smaller threat than a lot of these other things that we have in our environment. All right, geothermal energy. So this is energy, and it comes from the ground. So geo means rock, so and thermal means heat. So heat from rocks underground. So it comes from the radioactive decay of elements in the earth. Okay. Now, if we want to make a geothermal energy plant to produce electricity, here's how it works. Okay. They take cold water, they pump it into the ground. Okay. And when it goes down to the mantle, right? Remember, we've got like magma down here. When it gets near that, it's going to get really hot. So the really hot water is returned up here, and then it's turned into steam, which then turns the turbine and then creates electricity. So same idea, we're just using a different heat source. So rather than like we're burning coal, we're just pumping water down here, and then that natural decay is producing that heat. So one of the problems is that the groundwater can be depleted. So if we've got cold water going down here, typically it's going into the groundwater, and we can actually end up pumping this hot water out at a faster rate. There's also gases and steam that can escape from a geothermal power plant. So notice we've got to have these cooling towers. Okay, so heat, or like thermal pollution, right? Polluting by raising the temperature is a problem, right? Especially if this is by a big body of water and it's increasing the temperature of that water. One of the things that I want to take a look at is this ground source heat pump. So we can actually have a type of geothermal, it's called a geothermal heat pump or ground source heat pump in our homes, and it's a type of geothermal energy. So if we don't want to actually make a power plant, we can actually use this. This is a renewable energy because we're not going to run out of heat in our earth to heat our homes. So this transfers heat from the ground to a building in winter, or from the building to the ground in summer. So it's used to heat a home or cool a home. I'm going to play this little video. It's only 2 minutes, and then we'll finish the notes. right, so that was just an example. It's a geothermal technology. It's just called a heat pump, okay? So geothermal just refers to getting any heat or energy from the ground. So we can pump all the way to the magma and create a power plant, or we can just do it with individual homes where we dig a shallow area and put in pipes. So this is just showing you in the winter. Here's the winter, right? We end up pumping our water in here. It's cold to begin with because the outside's cold and the ground is warmer, right? So it's going to pump back warm water, and that can be used to heat the house. In the summer, the air temperature is warmer, so the water is going to be warm. The ground is cooler, so it's going to be pumping cool water back in and used to cool the home. All right, last but not least, I'm just going to touch on this. They do like to ask questions on the AP exam about this, but we're just going to go over it briefly. So the last thing that we want to talk about is a hydrogen fuel cell, okay? So here's what it does. It takes hydrogen and oxygen, and it produces an electric current, okay? So a fuel cell, think of it like a battery. Right? We get hydrogen going in, and then what it ends up in oxygen as well. And then water is the byproduct. Okay, so it's really clean because the only thing that's being produced is water and heat. Okay, so it's similar to a battery, but the cool thing is that you can keep adding materials, you can keep adding hydrogen, and so this battery is virtually rechargeable. Hydrogen's pretty easy to come by, right? Because it makes up water, H2O. It's pretty easy to find in the environment. And then what happens is that when you're braking, it actually captures energy and then stores it in the battery. So it's able to recharge itself while you're braking and while you're using the car. So this is one technology that they've been trying to use for cars, right? We've heard of electric cars. What's the problem with electric cars? Well, they still use electricity. And if they're using electricity, even though electricity or electric cars are not emitting any pollutants, they're emitting pollutants by the fact of that most energy is produced by coal in power plants. And that itself is making pollution. So what can we use to fuel our cars? Because cars are such a large part of the pollution in this country. So one of the ideas was we could use these hydrogen fuel cells. Well, the only problem with that is the fact that we need hydrogen fueling stations. So instead of going to a gas station, you'd go to a hydrogen fueling station. So one of the really nice things about fuel cells is that they're pretty efficient, whereas fossil fuels, power plants are not as efficient. But producing hydrogen, it takes a lot of energy to actually make the hydrogen gas. So we're having to use and put in a lot of energy, which could be generating fossil fuels. And then hydrogen gas is explosive and really hard to transport. So there you have it. We're done with chapter 13. I'm only going to be posting every other day from now on to get you ready for the AP exam. So let me know if you have any questions, and I will see you soon.